Great. I'd like to thank everyone who's joining us today. Welcome to today's CNCF webinar on how to promote the use of best practices and automate security policies using tools like OPA and Kubernetes Native Declarative. I'm Harry Lee, the lead DevOps consultant at Melio Consulting. I'm also the CNCF ambassador from Johannesburg, South Africa. I'll be moderating today's webinar, and we would like to welcome our presenter today, Gary Duan, CTO and co-founder at NeuVector. So a few housekeeping items before we get started. During the webinar, you're not able to talk as an attendee. There is a Q&A box at the bottom of your screen, so please feel free to drop your questions in there and we'll get to as many as we can at the end. This is an official webinar of the CNCF and as such is subject to the CNCF Code of Conduct. Please do not add anything to the chat or questions that would be in violation of that Code of Conduct. Basically, please be respectful of all of your fellow participants and presenters. Please also note that the recording and slides will be posted later today to the CNCF webinar page. With that, I'll hand it over to Gary to kick off today's presentation.
Thanks, Harry. Hello, everyone. Thanks for joining us. My name is Gary Duan. I'm the co-founder and the CTO of NeuVector. Well, as a company, we built the product of a fully automated container lifecycle security platform. So we focus on security visibilities, compliance, automation, and runtime protection. So today, my topic is to talk about using tools like OPA or other Kubernetes native declaratives to promote best practice and help you to automate security policy enforcement and auditing. So my agenda today is to first talk about why you should consider security from the beginning of your pipeline, starting from the development process and the CI/CD process. So as you move along in the pipeline, there are multiple stages you also should put security into consideration. After that, I will introduce some tools that can help you automate the security process. For example, the CRD, which is a Kubernetes native construct, and the OPA as well. So then I will demo some of the use cases. For example, using OPA to integrate with admission control in the deployment stage. And more importantly, at the runtime, you can also use OPA or these Kubernetes native tools to ensure the proper security policies get enforced. Then we go to the Q&A session. Well, this picture shows a typical cloud native containerized application pipeline. So you have the developers that are writing the code, and your build servers can gather all the artifacts and make an image. And the image eventually pushed to the registry. The image might go through the testing environment, and sometimes you put that into the staging environment, which very similar to your production. Then after all this is done, you push that into the production. Well, the critical vulnerabilities can get into your pipeline in multiple stages, right? Starting from the very beginning at the development side. Developers, they can make mistakes. They also rely a lot of open source libraries today. So those open source libraries can have vulnerabilities. In the build process, this build server, they can put together all the artifacts. A lot of applications today, they rely on external dependencies, open source libraries. They have vulnerabilities as well. So before you push your images into the registry, it should be scanned in the CI/CD process. Make sure you understand the risk in your image. After you push the image into the registry, so there are new vulnerabilities can be discovered. And if your image has life cycle more than a couple of days, a couple of weeks, you should consider rescan the image periodically. Well, in the whole process, you want to choose the tool to be able to integrate with your CI/CD pipeline tools you are using, no matter it's Jenkins or like a GitLab or Circle CI. whatever tools you want this security scanner to be able to integrate with them, so they can be fully automated. So as you move closer, say after your image are scanned and pushed into the registry, as you move closer to the production, you should also consider some other aspects, not just your applications, but the platform, the registry server, your container host, your Kubernetes platform, because those infrastructure components can be a target for the attackers. Think about a more traditional setup, right? Network environment. There are vulnerabilities discovered in Cisco switches, routers, network firewalls. They all have defects. Similarly, in Kubernetes and the Docker engine, we heard recently there in the past years, right? There are several critical vulnerabilities discovered. For example, in Kubernetes, there is one vulnerability can allow the attackers to hijack the control path communication. So in that case, you really want to make sure you understand what version you are using, what vulnerability they have, and keep them hardened, and do the benchmark checks, do the compliance checks, and upgrade your platform as well. But let's say you did all this. Is this enough? I would say no. Scanning is very important, but think about it. It's only give you the visibility to what you have known, what the reported vulnerabilities. One applications are running, their new vulnerabilities can be discovered, and sometimes those vulnerabilities, even very high, very critical vulnerabilities, they are not really they are not patched in the upstream. So you should consider the proper security tools in the production environment as well. Well, I believe today everyone already understands the importance of security, and your application should be protected. But how to secure these steps in the multiple stages in an automated way it's very challenging. You don't want to slow down your development velocity for doing the security, right? So this brings up the concept of security as code. So first of all, what is a security policy? There are different types of security policies. There could be a compliance policy, or access policy, or network policy, or something to do with the more operational side. For example, how you deploy, how you arrange your workloads. So most of them have something to do with your security controls in your environment. You probably heard about like infrastructure as code, policy as code. Really, this is a practice to describe your infrastructure or some of your high-level rules in a language. And this language are written as a text file. So because they are text file, you can do version controls on those policies. And it's much easier to compare your current state with your desired state. And if you see any deviation, so you want to kick in some logic and switch that back to the desired states. And also enable automations in different scenarios. I think traditionally, when we talk about if you have access, for example, Cisco routers and switches, those security configurations are typically written in command line script or some Perl script, right? So look at those CLI or Perl script, they really are some procedures. They don't describe any state, but the steps to get to that state. So it's not very easy to consume. And it's very hard to actually compare this with the desired security states. Well, luckily we are in a much better situation right now with the more modern platforms like Kubernetes. So from the operational side, for example, deploy your applications, to authentication, authorization, access control, all those rules, Kubernetes, what Kubernetes presents are really a set of rules that written in YARN file. They only described what you want things to be, but it doesn't say how it gets done, or how it's implemented. So this is the decoupling between the policy enforcement, actually the policy definition and how the policy gets implemented and enforced. So CRD is nothing but another set of YARN file that you can extend Kubernetes functions and APIs. Vendors like us, so we can introduce new CRDs, and we do all the hard work at the back end. So in order to support the functions that Kubernetes doesn't have, we do the same way, same as your Kubernetes workflow without changing that part. So let's say the configuration, your security configuration, your workload configuration are consumable, but the different systems, they have their own configurations. They can written in different ways. So how do we unify them? How do we use a high-level auditing process to validate if the configuration meets your policy, your rules, right? So OPA is one of the tools that can help you do that. So OPA is an incubating CNCF project. It is a generic policy engine. So it translates the high-level policies into a set of rules. And these rules are also written in declarative language. We call it Rego. So because it's a declarative language, it decouples where the decision is made. Typically, this is your Kubernetes or some load balancer or some other components that making the decision. Where the policy is enforced, I'm sorry, that's kind of reversed. Where the decision is made, it actually is in the OPA. Where the policy is enforced is in the Kubernetes and other components. So this enables several use cases. For example, there is a project called Gatekeeper that can be integrated with admission control. And also another project recently that can integrate with authorization process in the Istio and the service mesh infrastructure. Well, these two use cases, you can see this is more like an inline decision making, help you to make decisions on the policies and what can do, what cannot be done. So next, what I'm going to demo is a little bit different ways to use OPA to audit your policy, to check if policy or configurations match your high-level security rules. So let's start from beginning, from the CI/CD pipeline process. So you want to do vulnerability scanning at this step, right? So commonly these tools are delivered as a plugin integrated into your built tools, like a Jenkins here. This should be an automated process, right? So if configured rules cannot be met, the plugin should be able to stop the build and kick the image back to the developer, so the developer can fix or upgrade their libraries using that has the vulnerabilities. So you want to make sure you scan all the images, not just your applications, but also the public image in the public registry or some third-party images that if you are using them. So those tools should provide a rich context. For example, who introduced the vulnerability, when those vulnerabilities are introduced, the software component, and more details about the vulnerability. So say we have a tool. So today's, we have the plugin. Today's plugin normally allows you to set certain conditions. If those conditions are not satisfied, the build will fail. But what if you have some very complicated policy rules? How do you do that? So OPA is the tool. So here I have a very simple policy. So my demo will be like arranged this way. So first of all, you have a policy. This is your company-wide decision. So you want to enforce this. Here, the policy is the image, whatever image you have, they cannot have more than 2 vulnerabilities. Well, this is a very simple example for demonstration. But you can see on the right side that this is the policy is translated into Rego. It's very simple. So you can see there are only a couple lines. There's a package at the beginning. It's very similar. For example, if you're using Go language, this is the typical way you can define the scope. And there is a allow variable and a rule also named allow. So which has only 1 line. So essentially this is saying, okay, if the listed vulnerabilities count is less than 3, the allow value will be true. The evaluation of this rule will be true, and the image will be allowed to be pushed to the registry. But if the vulnerability is more than 2, then the allow value will be false, and the build will be failed. So let's go to look at the real examples. Yeah, so this is the Rego language I just showed. And as you can see, I lost my mouse. Yeah, get back. So as you can see, this is the input JSON file. This is the scan result generated by our scanner. The vulnerabilities are listed. Different software components also are listed. If you enable layer scan, the layer will be here, and the environment variables and labels are both, show here in the scan result. So you want to check if this scan result match your requirements, your policy rules. So now if we evaluate this policy language, this variable, we got false. The reason is false because your rule says the vulnerability count must be less than 3, and in your input file, you have more than 2. You have 3 vulnerabilities. So the evaluation failed, and the image should be kicked back to the developer. So by the way, I'm using Microsoft Code, and I'm using OPA plugin to help me to visualize this policy and also evaluate the value within this tool, within this. So this is a very simple example that you can integrate OPA into your CI/CD pipeline. So let's go to the next stage. So consider if your images are already scanned and pushed into the registry, going through all the tests and the staging environment. Eventually, you want to push that into your production environment. So you want to make sure the bad images won't get into your production cluster. So how do you do that? So there is admission control, which is a Kubernetes native constructive that allow you to set up some rules. And if those rules are not met, those pod or the images and pod cannot be get into your cluster. By Kubernetes itself, they provide something called the pod security policy, PSP profile, which can do the similar things. Basically, you can set up rules to say if the pod can run in privileged mode, if it can run as a root, or if certain volume and host paths can be loaded, or some other Linux capabilities can be enabled or not. This is a cluster level resource, so you have to bind that into a service account. So let's say, how do we validate this PSP profile using OPA? So we have a policy. The policy is no pod can run in privileged mode except for those in the admin namespace. So in the admin namespace, you want to give admin a little bit more freedom. You can do whatever they want. But in other namespace, you lock down, there's no privileged containers can be running. Well, if you return a PSP profile, it'll be something like this. So you can see, especially there's a privileged field attribute in the profile. The value is false, which means the pod cannot be in the cannot run in the privileged mode. Well, on the right is the codification of this policy. So this is more complicated. Let's switch to the view here. Oops. Huh. Oh no, I lost my mouse again. Okay. This is PSP. Okay. So we have a Rego file that translates the policy into this text format. So it's more complicated. As you can see, there are multiple rules. So in Rego, these multiple rules are logically owed together, which means if one of the rules is, well, in fact, if the rule have the same name, they are logically all together. If one of the rule, the evaluation is true, and this rule will be, this variable will be having the true value. And there are multiple lines within a rule, so they are logically AND together. So which means every line has to be true in order for the rule to be true. So in this case, you can see there are two allowed rules. So first one is to say there exists a spec, a PSP profile spec. The privileged variable has to be false. Their second rule is there exists a spec. The privileged variable is not true. It's not false, but the namespace is in the admin. So basically it says if it's in the admin, the privileged variable doesn't necessarily need to be true. If one of these two rules is satisfied, then the overall evaluation will be true. So as you can see, this is the PSP profile. The privileged variable is true. Actually, this should be false, I would say. And you have an input file. This input file first, let's say you want to evaluate, given a service account in a namespace, non-admin namespace. You want to evaluate what's the PSP file you eventually will apply. So we go back to the Rego file and do an evaluation. Well, the answer come back as true, which is you basically pass the auditing, right? You validate your PSP profile that can validate the policy, can make sure your policy is enforced. The reason is you are evaluating a demo namespace service account, and at the same time, your PSP file sets the privilege mode into false. So that matches that's exactly what your policy says. But what if we say you allow privileged mode, it define this for PSP file. But what you want to evaluating is admin namespace service account. So then what's the value is? So evaluate again. It also comes back as true. The reason is this time the second rule is matched. You are in the admin namespace, so the privileged attribute doesn't have to be true. It doesn't have to be false. So this just demonstrates how you use the OPA, writing multiple rules to translate your policy into a consumable declarative language. Well, the second part, the rest part of the file of this program, this Rego file, is to make sure what you are, service account actually is the profile you are binding with, because your PSP file has to bind to a row, and the row will be bound to the row binding in Kubernetes. So we just validate the PSP profile. So NeuVector, we have an admission control function which extended the PSP functions. It has the monitor and the enforce mode. So basically in the monitor mode, it's like a dry run your rules. If image doesn't satisfy, though some rules are not, are not met, we just raise an alert. We really don't stop that image from getting into your cluster. So this helps you to evaluate if your rules is written correctly. It also leverage the container image scan results in the registry scan or in your CI/CD pipeline scanning. So we can leverage that. You can define rules based on CVE's severity, if they are fixed or not, when they are fixed, all those functions. So let's see an example here. So the policy is you have some images. You want to say number of high level, high severity, very critical vulnerabilities cannot be more than 5 if they are reported for more than 30 days. The reason for this is some vulnerabilities are really reported very recently. You want to give some time for the developer to be able to test and upgrade their library. So you give a 30 days grace period to say, okay, so more than 30 days, you have to fix those things within 30 days. And you want to restrict this only, in all the namespace except the staging namespace. So this is to give staging a little bit more freedom. Go to the demo here. Let's open mission. By the way, all these examples will be pushed into the GitHub. You can play with it. So this is the Rego file that codified the policy. So you can see there are a couple of rules. So we check if the configuration, let's say the configuration first. So this is our NeuVector admission control configuration. So besides some default rules, we check, you can see the criteria here, we check if the high-level vulnerability counts, if they have fixed, when they are published, and we also see if they are in the staging environment, we just allow it, but if not, we just we need to make sure this rule is is enforced. So which can be translated. Well, you translate your policies into this Rego file. It also checks how your rules, how your admission control function are configured. So you want to validate that. So one thing I want to say is this checks doesn't mean to be complete, because there are different ways you can write your, you can configure the admission control. So if you really want to make sure every case is covered, your Rego policy check might be more complicated than this, but this is only for the demo purpose. As you can see, we check all these things. If the criteria you defined can enforce this policy, then we can evaluate this again. Well, unsurprisingly, the evaluation comes back as true. So this is the right configuration that can enforce your policy. Well, one good thing about Rego is you can do unit test with that. So for example, I write some test cases. Basically, you give certain different inputs, then you check if the evaluation result is same as what you expected. So you can run this to make sure your policies, your codified Rego policies are written correctly. So for example, easily you can do OPA test, then this will run all three unit tests. In this case, all 3 unit tests are passed. So this is really a good practice in the development stage. You want to make sure you don't have to run the real system, but you can check if your policy is correct. Well, yeah, so we just talked about the deployment stage, right? How do you prevent bad images from getting into your production environment? So once applications are running, so you should also consider how to prevent, how to mitigate the attacks. So here, the Q chain is really a model to map what steps that attackers will do to attack your system. So normally they start with discovering vulnerabilities in your system and try to exploit those vulnerabilities. They can download malware. The malware can be propagated within your environment, and eventually they want to steal some sensitive information and sell to the other parties. So a lot of this involves understanding of your network and understanding how to penetrate your network protections. They may scan the port. They may inject malicious code into your network packets, and they propagate from workload to workload in order to reach the sensitive information. If you look at these attacks on the right side, most of them have the network component involved. Also, think about this in another way. If a CVE, even they have a very severe kind of consequence, if they are not compromisable from remotely, if they cannot be attacked through through network, normally the score will be lower. So why we think the network security is really the first line of defense that can stop the attack and prevent that attacks to even get into your workload, your applications. So then on top of that, with the network security, you combine that with a system level detection logics. For example, you want to understand the process running, file system activities in your containers, in your container host, and you couple this with the knowledge of the orchestration system. So if you put this all together, it's more likely you can discover and stop those attacks. So let's go to, so we talk about the network policy, right? Let's go to some demo of the network policy. So network policy is a Kubernetes, its own construct. So here is a policy. So you have application in the demo namespace, they can only listen to one port. So the reason is your application should just do one thing. The second rule is the demo namespace, the application there cannot make outbound calls, calls to other components. So let's open the So this rule, this policy, high-level policy, I translated into this Regal file, and here's the input. Here's the data file. That this is Kubernetes network policy. Really defines what can do for application part. So we want to validate that. So here there are rules to check these two rules. I check to check. Well, they can only listen on one port, but they don't necessarily listen to any port. So that's why there is a second rule with the same name. And this one is to check, if the port selector and namespace selector is defined, then the external connection will be disallowed. So given this input, given this data file, you can do an evaluation of the input against the policy that comes back with true, which means, well, your network policy definition is correct. Oops. Well, so network policy has some limitations. For example, it has a limited flexibility to define inbound, outbound policies. So we extend that with our own CRD. So what you can do with our own CRD, it has much granular control of the inbound, outbound access control. You can define your policies, your network policies based on L7 protocols, application protocols, not just the port. So as you can see on the right-hand side, we define a network rule that can only talk to external address using the DNS name and the FQDN name using protocol Oracle. So you don't need to specify any port. You only specify what the protocol that connection can be used. We also can include the process and file system activities into this CRD to have a full profile of your applications. For example, here you are saying for any containers in your whole cluster, no SSH daemon can run. So which means, so this case is a little bit more advanced, because you can not only you define namespace rules, but you can define a global level security functions that make sure they are enforced. It is RBAC integrated with RBAC. Your system admin, your namespace users that have different accessibility to the functions and the rules they can define. Well, they will also provide the migration stage. We're going to show the demo there as well. So how do we audit the CRD functions? Again, so we have a rule. You have a rule to say your My App application can only connect to Oracle database outside of the cluster. And there's no container can run SSH daemon. So that's exactly what our, the policy I just showed earlier here. So that's the CRD YARN file. You can import that into Kubernetes. But how do we validate that this CRD file, can satisfy this policy? So this is the Regal file you write. Let's go here. CRD here. This is the CRD file. It's the same as we we show in the demo, in the screenshot. And here is the rego file that to check that CRD. So without going to the detail, we do an evaluation. So it's true, good. Yeah, so which says the CRD profile you defined for that application met your overall high-level policies. Well, so as I said, we provide a way to migrate your CRD policy defined in CRD from the staging environment. For example, you do the unit test, you exercise all the passes of your application logic. Then you want to migrate this CRD into the production. So your CRD is a YAML file, right? So your deployment file of your application is another YAML file. You just deploy them together into the production. So once the application starts running, you can be sure your security policies get enforced as well. So I can quickly show the procedure here. This is our UI. Yeah, so you have all the visibilities you want to have. For example, you can look at the node, you can look at the containers, registries, and our own components. And most importantly, you can define groups, which can be defined in labels, service, namespace, and you can define network rules. So here, for example, I did all my unit test, and I know all the application logic exercised. So I want to export the security profile into a CRD for these 3 applications. This is our demo app. So here you can do the export here. So basically it will be exported as a CRD. And you can see this is very much the same as I just showed earlier. It's a CRD file. And you can migrate this together with your application deployment file in your production. So here, this is, we are using a multi-cluster management setup. So here is one setup, one cluster running in GKE. And for example, we switch to another AKS cluster. Yeah, I don't want to run the import again, but you can see here we already import. We already did the kube control apply of the CRD YAML file on this setup. So you can see their groups are marked as CRD, which means they are imported from the CRD. So there are groups here, and their network rules are also marked as CRD. So they actually imported from the CRD YAML file, and they can be, start protecting your applications once the applications start running. Yeah, so we talk about some techniques that help you automate the runtime security validation and how to migrate your policies into the production. So most of the real world applications, they have to run with vulnerabilities. So you really need to have the confidence to run your application without worrying that, well, your application can be compromised. How do you build that confidence? So with this runtime security protection, they continuously check the security postures and the security state and the activities, so they can actively remove or stop those attacks and undesired, unwanted activities. So even you have a vulnerability in your applications, you can consider those vulnerabilities are virtually patched. So that's the that's all for the demo. A quick summary. So we talk about why you should build security into your pipeline from the beginning to the end, and why, how to automate vulnerability scanning, how to use admission control to gate the deployment, and how to protect your application in the runtime. So we demonstrate how to use some of the tools like CRD, like OPA, to audit and enforce your security policies. Yeah, so that's all for my topics. Yeah, any questions? If you want to explore our product, you can go to our website, NeuVector.com, and you can send email to our representatives. I'm here to answer your questions.
Awesome. Thanks, Gary, for a fantastic presentation. So we now have some time for questions. If you have a question for Gary that you would like to ask, please drop it in the Q&A tab at the bottom of your screen, and we'll get to as many as we have time for. Okay, so I do have a few questions here. So Gary, the first one is from Ken. What Visual Studio Code extensions are you using for OPA?
Well, this is, I believe this is developed by Sterra, so they are behind OPA. So this is the, you can search the plugin, the extension Open Policy Agent. I think that's the very first on top of it. I just use that. Okay,
thanks. So can I use OPA with pipeline or image scan results? And are there any examples on this?
Right, so you really want to automate that as well. Yeah, so as I said, a lot of plugins allow you to put certain configurations, very limited configurations. But because those scan results normally comes back, typically they make REST codes or they make some process codes. The scan results come back as a JSON format, for example, right? So that's easily consumable with the OPA engine. So we kind of did a very easy demo, very short demo on that. It can be totally automated within the plugin or in your pipeline. So you can validate the result and check. You can define more complicated rules to either fail or pass this image in your pipeline. Yeah, so it totally can be automated, can be using OPA to do that.
Okay, great. Thanks, Gary. And the next question is, can you please clarify whether OPA policies can only be defined in regular language files using its object structure or other language such as YAML? Any comments on that?
Okay. Well, yeah, so using OPA plugin here, there are two different concepts. One is the data file, one is the image input file. The input normally is something you want to validate, and the data is something at the back end. So you want to use that as part of your validation process. So in my demo, we kind of use that both in some cases. It can be in the YAML file, it can be in the JSON format, but the Rego language itself has to be in that format, right? So they have multiple rules. Each rule has multiple lines. So that's Rego, but your input or your data file can be in YAML or in JSON. So that's normally the data you feed into OPA for the evaluation.
Okay, great. The next question is, can I trigger other actions than just allow or deny? So for example, webhook to Slack or Kubernetes log entry with a certain alert line.
I don't think OPA itself does that. Well, definitely the OPA project person is the best to answer this. I don't think that's the job for OPA, because OPA is just to make decisions, right? Giving the input, make decisions. You send some JSON or YAML file into OPA and it comes back with certain evaluation. But you can, based on the evaluation result, you can trigger other actions. So normally this is either some response rules, or some of the, for example, you want to send a webhook, you do some other logging. So this is your where the enforcement should be happen, where the notification should happen. It's decoupled from OPA. I believe that's not OPA does. Yeah.
Great. And the next question is, can I use OPA to query all of my CRD policies written in YAML in my Git repo?
Okay, so well, that's a very good question. Right. So for example, OPA is really a very lightweight engine. So there are different ways you can integrate. They have a REST API interface. You can even integrate that with your Go applications. For example, you have some rules written and you push that into GitHub, then you can use those CI/CD pipeline tools like Travis, like a SQL CI. Once you push a pull request, the CI process can be invoked. So over there, you can use OPA to validate your changes. Then if this is a unitized process, and if that pass, then at least there's an indication so to say the policy you just write is correct. It can be merged. So definitely this can be automated. So in my demo, I use a plugin. It's more like a manual process, but there are different ways you can integrate, automate OPA process.
Great, thanks. So in your demo, you showed a NeuVector network rule CRD. Can that be enforced by network policy or IP tables?
Okay, so my understanding of this, there are multiple faults here. Yeah, so this is an extension to the Kubernetes native network policy. The Kubernetes network policy only defines network rules, right? So we also, on top of that, we have the process rules and the file system activities rules as well. And we do also the RBAC based, given different accessibility to different namespace user or global admin. Our enforcement, we also do the monitor mode and the protect mode. So in the monitor mode, we only raise alert if there's a violation. So in a way, we kind of implement our own logic to be able to either monitor or intercept the traffic, so we can stop for example, the attacks, the bad packets, or some sensitive data get leaked. You want to stop them on the fly, so we can do that. We try to do this in a very graceful way. So we don't install like kernel modules. We don't use IP tables because that can, well, first of all, it has performance issue using IP tables and when you create so many rules, and it also can get together with other your network plugin. I use IP tables as well. So we don't want to get into that. So we kind of coexist with network plugin and work together with them. But we have our own implementations to make the packet inspection or protocol analysis faster. So that's how we implement our network functions.
Cool, thanks, Gary. Is NeuVector open source, and how do I try it?
Well, as I said, all these examples will be open source to push to GitHub. We also open source all of the compliance checks of the platform. For example, the benchmark checks, and we also open source many plugins to your CI/CD process. For example, the Jenkins, Circle CI. I think Azure team, we also open source that in our GitLab account. So that's some major components, the benchmark compliance checks and Jenkins CI/CD plugins. We open source that, so you're welcome to use that. And we have some monitoring tools that we open source that you can use to in your applications, in your environment.
Okay, great. So thanks, Gary, for a great presentation. And that is all the questions we have time for today. Thanks for joining us, everyone. The webinar recording and slides will be online later today. And we're looking forward to seeing you at a future CNCF webinar. Have a fantastic day.
Thank you.
Thank you so much, Gary.